Hello friends, today we are going to learn general vectors and notation, position displacement vector and vector explained using displacement as prototype. So first we will see what is vector. A vector has magnitude as well as direction. If anything has magnitude and direction, that is called vector. And vectors follow certain vector rules of combination. If we have to add is, we have to multiply, or we have to subtract, then we have to follow certain rules for combining the two vectors. We can't directly apply simple algebra in the vector for addition and subtraction. For example, what are the examples of vector? Suppose we are going from A to B. So we have changed our position from A to B in this direction. So this arrow is showing direction. This is the representation of a vector. Vector is represented by one arrow at the last corner of one line. So this is the representation of a vector. Example of vector are, this is displacement, velocity, acceleration, etc. Now the second is scalars. Scalars have only magnitude and no direction. Examples of scalars are pressure, temperature, energy, mass, etc. Pressure, you can say that 5 megapascal. Temperature, you will have 5 Kelvin. Energy, 5 kilojoule. Mass, 5 gram. You will tell directly that these have only magnitude. It doesn't matter or doesn't think about the direction. Only you have to tell 5 gram. In which direction it has gone 5 gram, it doesn't matter in which direction it has gone 5 gram, because it has only a scalar quantity. It doesn't matter with the direction. So simply you will tell 5 kilojoule I have energy. Today's temperature is 5 Kelvin. Today I have applied 5 megapascal pressure. In which direction I have applied doesn't matter, because pressure has no direction. Pressure you will apply in which direction, that you will tell, but pressure is a scalar quantity, it has only magnitude. Now the vectors explained by displacement vector or change of position. So in this I have told you this displacement vector in previous lectures by animation. So you can go and see that video that I have explained in very efficient way. In that video I have explained by animation, so you can understand the difference between distance and displacement. So here also we can see that first concept. Here I am explaining vectors by displacement vectors. So in this we will see the first concept. Suppose we are going from A to B. So A to B, I have changed our position. From A position to B position, I have changed our position. And in which direction I will go, so that I will cover the minimum distance. So from A to B, I will go in this direction, then I will cover the minimum distance. So what is the first concept? First concept is, by changing position from A to B to cover minimum distance gives displacement vector. First concept is clear. Now second concept. Second concept, we will see that A to B we have gone. Same color I will use. A to B we have gone. Same displacement vector, that what in upper figure what I have drawn, same displacement vector. So now from A to B I can go from this path also. From this path also we will travel from A to B, and this path also we will travel from A to B. But displacement vector, what displacement vector is telling you? We have gone, suppose I have gone in this way. This is our path of motion. This is my path of motion. But A to B displacement vector, this will represent the displacement vector. It is telling us directly the overall effect of the motion. It doesn't tell about the from which path I have gone. So what is the concept? Concept is, don't tell us about motion path. Only tells us about overall effect of motion. So it is only telling an overall effect of motion, which is telling us displacement vector. Now the third concept, for third concept we will see with three vectors. This is first vector, this is second vector, and this is third. Now the first vector A to B, second vector A dash to B dash, third vector A double dash to B double dash. So here you are seeing that from A to B same displacement, because it has what A dash to B dash has the same magnitude as A to B. So A dash to B dash has same magnitude as A to B and having same direction as A dash to B dash and similar to A triple dash, A double dash to B double dash. So all three have same magnitude and direction, but the only difference is its position has changed. This is from A to B, this is from A dash to B dash, this is from A double dash to B double dash. Suppose this is, I am going in India from A to B, in America from A dash to B dash, and in Africa from A double dash to B double dash. So in three different places we are following the same displacement vector. So if they have same magnitude and direction, then what we can do? We can shift the any displacement vector to any place if they have same magnitude and direction. Suppose we have done here. So now it will become A triple dash and B triple dash. So it will be deleted. So What is the conclusion? If having displacement vector having, here is displacement vector having same magnitude and direction, then we can shift their place. We can shift their places. Now the fourth concept. So for fourth concept, we have to see in 3D and 2D and in plane. So suppose you can see that you have A4 paper. That A4 paper is nothing but a plane because it has negligible height. So it is a plane. So in that plane A4 sheet, this is your one side corner. So from this side corner, you will draw one vector A to B. So this A to B is representing displacement vector in 2D or plane. Now the third thing, suppose in your room you are going from one corner to other corner. From this corner to this corner you are going. So same displacement vector but in 3D. So displacement vector I will directly write dv in 3D. So this displacement vector in 3D because this is x axis, this is y axis and this will z axis. So this displacement vector in 3D. So we have all four concepts. We have seen our all four concepts. So today we have studied general vectors, notation, position and displacement vector. Vector explained using displacement as prototype. So this thing we have studied along with in 2D and 3D. So thank you.